Okay, good morning everyone. So today we will be learning about fieldwork number 3, and that is determining area of a tract of land by transit and tape. Now this fieldwork comes after fieldwork number 2, which is orientation, setting up and leveling the engineer's transit. Now fieldwork number 3 is actually a practice on how to operate engineer's transit after we have learned the different parts and how to set up and level the engineer's transit. So we have here the objectives. Number 1, so we are going to apply the different principles on how to operate the engineer's transit and its different parts. The second is to measure horizontal angles using the horizontal scale and vernier. And lastly, we have the third objective, to compute the area of a closed field or closed lot or land using the principles of trigonometry and geometry. Now, after we have done with this fieldwork, we should be able to develop our skills in measuring angles using the transit, and we will be able to determine the area of a closed polygon or a closed lot using the principles of trigonometry and surveying techniques. It is, however, very unfortunate for us class that we cannot have or perform this fieldwork because of our situation today. So all you have to do is get acquainted with the procedure, and somehow in your career you will be able to determine the area of a certain tract of lot using this procedure. Okay, so we have this procedure. So first, we are going to establish corners of a lot. So we will designate that as our station A, station B, we have station C, D, and E. Okay, after establishing those corners, those assumed corners of a lot, we'll be establishing another point here, an imaginary point here, somewhere in the middle of the lot. So we can designate that as point F or station F. Then afterwards, we are going to set up and level our transit here at point F. Okay, so after setting up and leveling our transit, we are going to site A. Okay, so after sighting A, we are going to swing our transit and we are going to sight B to determine our angle theta A, and that is for the triangle ABF. Now, as you have noticed class, F here is an imaginary station. So that means after establishing station F, as you can see, the whole lot is divided into a series of triangles, and that is triangle ABF, DCF, CDF, DEF, and EAF. Okay, with their corresponding included angle theta B, theta C, theta D, and theta E. Okay, now while the instrument man is determining the angle theta A, B, C, D, and E, the head tape man and the rear tape man will be determining the line or the distance between A and F. So that is side AF, and then we have side BF. Next we have side CF, DF, and EF. Okay, again, while the instrument man is determining the angle theta A, the head tape man and the rear tape man are measuring distances AF, BF, CF, DF, and EF. So that means the procedure or the operation is somehow simultaneous while taking included angle theta A, theta B, C, D, and E. The head tape man, or rather the head tape man and the rear tape man are determining the sides AF, BF, CF, DF and EF. Okay, so after determining those values, we can now return to our respective classrooms or offices. Okay, so I'll show I have here tabulated and assumed value for theta A, B, C, D, and E. So those are observed values. Okay, now also here we have the lengths AF, BF, CF, DF, and EF. Okay, now the first part of our computation is adjusted included angle. We are going to adjust our observed angle. So we have here the observed value, determining included angle. So why do we have to adjust our angle, observed angle? Okay, the answer is will be further discussed later. Okay, so we have here first is the computation of included angle. As you can see, we have here the solution. So if we are going to sum up all the included observed angle like this one, it resulted to 365 degrees 31 minutes. Okay, I want to remind everybody that this is just an assumed theta. Okay, so the result is 365 degrees 31 minutes. But in our geometry or trigonometry, when you try to add theta A, B, C, D, and E, it should result to what? To 360 degrees. That means we have an error. So how are we going to compute our error? So that will be observed sum minus theoretical sum. So that will be 365 degrees 31 minutes minus 360 degrees 0 minutes and 0 seconds. So we have the value or the error of 5 degrees 31 minutes. As you can see, this is positive. So positive means we have an excess of our observation. So we have an error, an excess error. Okay, if this value is negative, okay, that means we have a deficit. Bot pasabot ang ato ang observation sa mga angles here is kulang. Now, since this is positive, so obviously our observation is in excess. So next is we are going to compute the error per angle. So we have the error, total error, angular error, divided by 5. Why 5? Because we have 5 observations or 5 angles. 1, 2, 3, 4, and 5. Okay, so that gave us a value of 1 degree 6 minutes and 12 seconds. So after computing error per angle, we can now compute the adjusted included angle. So theta A prime is equal to theta A, the observed value, plus and minus error per angle. Why plus and minus? Because if our total error is in excess, that means we have to subtract our error. If this is deficit, of course we will going to add the error per angle to the observed value. So since this is in excess, both pasabot nanubra ta. So we have here 40 degrees, the observed value, minus the error per angle. So it gave us the value of theta A prime. So you do that to the remaining angles, we are going to minus the error per angle. Okay, so these are the values. Okay, the values of the adjusted included angles for each angle. Okay, so before we can go any further, make sure to check if these values, when you try to sum them up, it should be equal to 360 degrees. If somehow when you try to add them up, if it will not result to 360 degrees, then there's something wrong with your computation. It should be equal to 360 degrees, no more and no less. Okay, so afterwards you are going to copy this one here. Okay. Okay, so let me just adjust this space. Yeah, never mind, no. Okay. So we have here for adjusted angle B, we have 4. Okay, make sure class that your data tabulation should not be empty. It should be filled with data. Okay, make sure it should not be left empty. And we have the correction. The correction is the correction per angle. Okay, controls C. Okay, so we can have, or we can put minus there. So the interpretation of the table now is the observed value minus the correction is equal to the adjusted value, as you can see there. Okay, so next we are now ready to compute the area. As you can see here, as what I've said, our lot is divided into a series of triangles, okay, with their included angles. That one, AB, A, theta B, C, D, and E. Okay, now there's a purpose why we measured the length of AF, BF, CF, DF, and EF. Okay, because of this principle. As you can see, we have here a triangle with two adjacent sides, A and B, and an included angle. Okay, if you can still remember your trigonometry or geometry, the formula for that given triangle is we have 1/2 AB sine of theta. Our theta there should be the adjusted included angle. Okay, so as you can see in our tabulation, okay, so for triangle ABF, our A side is AF and our B side is BF. Okay, right here. So triangle ABF, our A side is AF and our B side is BF. So we will just copy this one here. Okay, next for angle BCF, as you can see, angle BCF, our A side now is BF, our B side is now CF. So all you have to do, as you can see, our A side is BF, our B side is CF. Okay, that one. So all you have to do is copy those values here. Okay, and we have AF there. Okay, so, and as you can see, we have the adjusted included angle in the tabulation of area computation. That means whatever values you have here, all you have to do is you are going to copy that there. Okay, so we have now the sides AB for each triangle, and we have the adjusted included angle. So we can now interpret the tabulation of area computation. Okay, that means for triangle ABF, we have the area for that particular triangle is 1/2 A multiplied by B multiplied by sine theta prime, which is the included, or rather adjusted included angle. So the computation now is here. So triangle ABF is 1/2 AF times BF times sine theta A prime. So that will be 1/2 35.25 times 55.32 times sine theta A prime. Where is theta A prime? Here, theta A prime. Okay, So the next is triangle BCF. So for triangle BCF, our A is side BF, our B is side CF, and our adjusted included angle is 81 degrees 9 minutes and 3 seconds. So here we have the adjusted included angle for B. Okay, so we have here the area 565.37. Then do or compute the remaining triangles using the tabulation here. Okay, that one. So now if you are going to sum up these values, it will give us the total area of the lot. So we can now copy this one. Okay, here, right there. So you can copy this one each here. That is for area ABF. We have for area BCF, we have for the third one CDF. Okay, and we have for DEF, and last we have EAF. Where is that? Yeah, this one. You have EAF. Okay, so that fills out our tabulation for area computation. So if you are going to sum up all this area, it will result to 2,585 point what is that, 35. Okay, let me just adjust this one. Okay, so this is an example on how you will be computing your data right there, no? So make your computations neat and clean, no? If possible, make your work or minimize your work from erasures. Okay, so afterwards you are going to sketch. We have here an instruction: draw to scale the actual figure. When you say actual figure, based on the adjusted data, that means whatever your length here for AF, whatever your length there for BF, and the included angle right here in length AF, BF, and included angle theta A, the adjusted included angle, then that should be 35.25 for AF, and that should be 55.32 for BF. Do not, okay, I remind you, do not copy this one. Okay, do not copy. This is not drawn to scale, so you have to draw whatever your distance is here and your adjusted included angles. Okay, if you will not be doing that one, then I will notice it. Okay, so you are going to draw that here. You label all angles, all stations, and all distances. Okay, so you have the instruction: label all values completely. Okay, draw to scale the actual figure of the field based on the adjusted data. Label all values completely. Okay, afterwards you are going to have your conclusion. Okay, class, make your conclusion as brief, concise, and your conclusion should reflect what you have learned in the field work. It should not be like, for example, therefore I conclude that first we establish station A, and then we set up our transit at station F. So that is not conclusion, that is procedure. So your conclusion should reflect of what you have learned in your fieldwork. Okay? So after having your conclusion, we have here our space for surveyor. So do not forget to write your name and your signature. Leave check by blank. Now leave this blank. Okay? So that will be the procedure on how to compute the data of our fieldwork number 3. Okay? So some of the students or some of your classmates asked me, Sir, pwede ba may makagamit og transit unya, sir? Or like if mag-normal na ang panahon niya, mag face-to-face na tag klase, pwede ba may makagamit sa transit, sir? Or maka-operate man lang? The answer is yes. No? If you have free time in your schedule niya, mamalik na ta sa eskwelahan niya, you are very interested, no, with transit or other surveying instruments, then you can, no, if you have free time, go to the CE laboratory, you borrow instruments, and then you try to venture engineer's transit and other engineering, civil engineering surveying instruments. Okay? So para somehow dili pod mo maignorante sa tuang mga surveying instruments, especially maabot na mo sa inyong OJT. So pahandulon mo transit or theodolite, dili na ta mabalaka or ma-anxious on how to operate and do surveying fieldworks. Okay? So I think that's all for now, and make sure to pass your fieldwork number 3 on a designated deadline. Okay? Thank you.